Hello and welcome to Algebra 1, Lesson 4-2. Today we're going to be learning how to add and subtract polynomials. But before we do that, let's go over a few of the terms that we're going to need to know to be able to do this proficiently. The first term is, what is a monomial? Okay, a monomial could be a number. It could be like 14. Okay, it could be that's what we call a constant. A monomial could be this. There's just one of them. Or it could be this, 2x. Or it could be x, y squared. As you can see, each one of these is just made up of one term. We have a 14, a 2x, and an xy squared. Those are called monomials. Now the next step up is called a binomial. Bi means two. And if I combine two of these together, if I combine 14 plus 2x, I would have what we call a binomial. There's two terms here, and because there's two, we call it a binomial. If I add another term here, let's say that's just going to be y, right now I have a trinomial. And they keep going up and up. After trinomials, they usually call all of these expressions polynomials. Okay, they'll even call this a polynomial. Poly just means many. The only expression that's not a polynomial is a monomial. Okay? Now, before we start to add and subtract, okay, there's a couple more things that we need to go to, and a lot of times on a test or a standardized test, they're going to ask you, and they're going to say, what is the degree of this monomial? What is the degree of this polynomial or binomial or trinomial? Okay, it's very simple. The degree of any, let's look at this monomial. The degree is the exponents. You see this is a y, but on the y there's a 1 here. It's the addition of all the exponents. So I have a 2 plus 1 is 3 plus 4, and the degree of this monomial, the degree is 7. Okay, that's the degree of this monomial. Now when you go to a binomial, trinomial, or polynomial, you take the highest degree of each of the highest degree of the term. Meaning, if we look at this one here, r squared s minus 3rs cubed plus 2r to the cube s to the second plus 5. What we're looking for is the highest number when we add our exponents together. That will be our degree, just in one of the terms. So in this case, I'm going to have 2, and this is going to be 1. So the degree here would be 3. This would be 4. This would be 5. Okay, so for this entire polynomial, the degree is going to equal 5.
Do I count the exponent on the number?
Well, it's a 1.
But
No, we don't count the exponent on the number, because this is a constant. Okay, so our degree in this case will be 5. Okay, so the degrees, just to recap, the degrees are the exponents that are attached to your variables. When you add them up, it is the highest value. Okay, and as you can see, this I'm going to be doing this problem next, which is going to be an addition problem, and we're going to talk about what are like terms. Let's see if we can find the degree of this one. All right, let's look at the degree before we even start. Okay, I've got an x cubed, an x in the second, x in the third, and the fifth. So the highest exponent on any of my terms is 3. So this polynomial will be classed degree 3 will equal 3. Okay, now we should talk about what is a like term. I'm going to go ahead and erase this. What are like terms? Well, like terms sometimes are called similar terms. I like them called like terms. It's just like animals. A cat is a cat, whether he's green, red, purple, or blue. A cat's a cat. And a like term is sort of like that. Sometimes you're going to have an x. We'll call all x's, we're going to be cats. All right? Sometimes I have a yellow cat. Sometimes I have a brown cat. Sometimes I might have a red cat. And what I'm trying to say here is sometimes in front of our variable, which this is the thing that classifies whether or not it's a like term. You can have a constant in front of this, and this is what you look for to see if they're the same. So for example, 2x plus 5x plus 1x. All of these are cats. They just may be different color. So we don't really pay much attention to the constant in front of the variable except that we add them together. So if I have 2 blue cats, 5 red cats, and 1 yellow cat, how many total cats do I have together? Well, 2 plus 5 is 7 plus 1, so I'm going to have 8 cats. And that's how we do like terms. And a like term can also be written in a different way. For example, if I had this, x squared y, I could rewrite it as yx squared, or I could write it as xyx, or I could write it as yxx. Even though they look a little different, they're still the same. I always have an x squared. Yes, I do. Yes, I do. When I multiply these together, yes, I do. And these, yes, I do. And I always have 1y. 1y, 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 1y. So all of these are what we call like terms. Now we're going to use this knowledge, and we're going to combine all of our like terms in this problem. Okay? Even though they may look a little different, you can rearrange them, and if they are exactly alike, they are alike, then they are very much like terms. Okay, let's look at this problem over here. All right, in this case we have an x cubed, an x squared. Those guys aren't the same, they're not alike, but we have another x. So I'm going to go ahead and underline the 2 like terms here, and then I'm going to go ahead and underline with 3 lines the like terms here. And I have one term that is a numerical value, and the only thing that's a like term with him is another numerical value. But I don't have another one, so he's just going to have to remain 5. Now what I'm going to do is I'm going to pretend I'm going hunting. I'm hunting now everybody that's in the x3s. Okay, let's just say that these guys are peacocks. All x3s are peacocks. X to the 3rd power. Okay, so I'm going out, oh, I found one. He was hiding in the bushes. So I have minus 6x to the 3rd power. I caught one. I caught this guy. I go hunting a little bit more. Oh, here's another guy. This guy was hiding in Grandma's basement. And we keep the sign, which is right here, 6x cubed. Now what we do is we add the coefficients here. Negative 6 plus a positive 6 is a 0. So I'm going to end up with 0 times x cubed, which is a 0. So basically, this term and this term are going to cancel each other out. Boom. All right, so let's go hunting walruses. X squared is what we call a walrus. Okay, let's see how many walruses we can catch. Oh, here's a walrus right here. 6x squared. So we're going to write him down. 6x squared. And he was screaming and howling because he didn't want to be caught. Oh, here's a baby walrus. He's only an x squared. He kind of wanted to be caught because he was hungry. So there's not a number in front of my x squared, but there's an understood 1 here. So 6 plus 1, okay, my answer is going to be 7x squared. Okay? Now the last thing I'm going to say is I'm going out hunting, and the last guy to hunt that I find is a 5. It's a porcupine. Nobody wants him. Can't combine with anybody, but we still have to include him. So the porcupine just comes back as a 5. Now, I have a positive 7x and a positive 5. I rewrite. After I combine and catch all my animals, it turns out to be 7x squared plus 5. Now, my question to you is, what's the degree of this binomial? Well, it's the highest exponent. So in this case, the degree would be 2. Okay, so the degree here is 2. All right, now, let's look at a little more complex problem. Okay, where you're going to have to put on your thinking cap. We're still going to go hunting, We're still going to collect all the animals that are the same, and we're still going to add them or subtract them depending on what the problem asks for. Okay, let's look at this problem here. They say subtract, okay? So I'm going to write this down here. Subtract. Okay, and they're going to give you two polynomials. It says negative a squared minus 5ab. Let's start way over here. Negative a squared minus 5ab. It's going to be a long one. Plus 4b squared minus 2. Okay, we're going to subtract. We're going to subtract this from. See how they're writing this down? They're not really writing it down in algebraic form. We're going to subtract it from 3a squared minus 2ab. 3a squared minus 2ab. Three a squared minus 2b squared minus 7. Minus 2b squared minus 7. Let me just make sure I have that correct. Okay. Okay, so it says we're going to subtract. We got to put on our thinking hats. We're going to subtract this term, subtract negative a squared minus 5ab plus 4b squared minus 2 from this guy. So we're going to rearrange it. It's written here so that you will be confused. It's just like saying subtract 5 from 10. So you would take 10 and you subtract 5. So I'm going to rewrite this in the form that it should be. I'm going to take this one and subtract it from this one. Okay, so I'm going to rewrite this as 3a squared minus 2ab minus 2b squared minus 7. Then I'm going to subtract it, and I'm just going to put these in parentheses, okay, from negative a squared minus 5ab plus 4b squared minus 2. Now here's where we usually get into a problem when we subtract. Do you see this subtraction sign here? Every single term inside my parentheses, the sign has to change. Now, Miss Moran always calls these guys wild and scary animals. And before we let them out of the parentheses, we got to change their names so we know who they are. See, the way they are now, we don't know if they're scary or not. They're going to eat us up or what. So, before I do anything, I'm going to go ahead and go through here, and I'm going to change my negative sign to a plus and change everything in here, the sign of everything, to the opposite. It's just like taking a negative 1 and multiplying it through all of these terms. So I'm going to change the negative sign to a plus, and I'm going to change all of their names. So it was a negative, it's going to turn into a squared. It was a negative, it's going to turn into 5ab. It was a positive, it's going to turn into 4b squared. And it was a negative, it's going to turn into positive 2. Okay, now, I've changed my subtraction problem into an addition problem. Now I'm just going to put the first part of the problem down, 3a squared minus 2ab minus 2b squared minus 7. Okay, let's look at the type of animals that I have. Okay, well, the first type of animal is an orangutan. And he's an a to the second power animal. The second one, AB, is a hippopotamus. The third one is a b squared animal. And he is a giraffe. And then I have a, I'm going to say a number. Okay? A numerical value. Okay, now I'm going out hunting. I'm going to go and look for all the a squares I can find. Oh, I see some. I see this guy here and this guy here. Now when I underline them, I want to make sure that I take the sign with it, because I'm not going to know whether to add or subtract it without the sign. So in this case, this is a positive 3a plus a squared. And where I have the a squared, I went out and I caught two of these guys. I caught a 3a squared, and I caught an a squared. And that's going to give me a positive 4a squared. Let's look at my ABs. Ooh, here's some right here. I got a negative AB here. Oh yeah, positive 5AB here. So I'm going to rewrite that. I'm going to have negative 2AB plus positive 5AB. And when I add them together, I get 3AB. Let's go hunting the B squared. Oh, I think these guys are rhinoceroses. Oh yeah, they were really mean. There's one there, and there's one there, and they just both happen to be negative. So I have a negative 2b squared, okay, plus a negative 4b squared, and it's going to be a negative 6b squared. And the last ones are my numerals. I have a negative 7 here. I'm going to circle around him, and a plus 2. So negative 7 plus 2 gives me a negative 5. Now when I put these together, I look at the signs and I know what to put, a plus or a minus, and then I'm finished. I add all my like terms together. So my very first term is 4a squared. It's positive, so I write him down as 4a squared. Okay, and I check him off. My next one is positive, plus 3ab. Okay, I check him off. I've got him done. Next one is a negative number. So negative 6b squared. Check him off. And then the last one is my numeric value, which is minus 5. Okay, from all of this, we see that we've simplified it down and we collected all the like terms, and we end up with 4a squared plus 3ab minus 6b squared minus 5. And what is the degree of this polynomial? It's 2. Okay. And that's basically all there is on this lesson of like terms, adding and subtracting.